Hello everyone, welcome to ICSE Physics, keeping intellectually engaged. Today in this session, we are going to solve a couple of typical numerical problems of chapter 3, machines. Please watch and practice. Let us begin. Please have a look at the question on the screen. A block and tackle pulley system is used to lift a load having 4 number of pulleys. It lifts a load of 450 kg through a vertical height of 20 meter. The effort applied is equal to 250 kg. The questions are: find the work done on the load. Second, find the work done by the effort. Third, name the 2 types of work done. Fourth, calculate the efficiency of the system. And the last one, draw a diagram of the system. Let us solve. First, we will note down the quantities given in the question. Number of pulleys. Number of pulleys is equal to 4. Therefore, the velocity ratio must be equal to 4. The value of load is given, that is 450 kilogram, that is equal to 450 into 10, 4500 Newton. Distance travelled by the load given, dl is equal to 20 meter. That is the distance travelled by the load in the vertical direction. Okay. The effort applied is equal to 250 kilogram. The value of effort is equal to 250 kilogram. 250 kg must be converted into SI unit of force, that is 250 into 10, that is equal to 2500 Newton. All right. Yeah. We will start with the last question, that is draw a diagram of the system, which is already drawn there. As you know that, have a look at the diagram here. A block and tackle system consisting of 4 pulleys, 2 in the upper block and 2 in the lower block. So you know that when a pulley system consists of 4 pulleys, 2 pulleys are in the upper block, 2 pulleys are placed in the lower block, and we start attaching this rope from the hook of upper block. Number 1, number 2, number 3 and number 4. Pulley number 4, and we get the free end here where we apply the effort, and tensions are marked as shown in the diagram, which is always moving upward along the 1, 2, 3, 4 segments of the rope, and load is balanced by 4 tension acting along the 4 segments of the rope. Effort is balanced by the tension here. So that part is over. Now here we will move in the reverse order. Now starting with the diagram, last D part is over, diagram is drawn. Find the work done on the load. Work done on the load. You have to calculate work done on the load. Work done on the load, WL is equal to, you know the formula, load into displacement of load. What is load given there? 4500 into 20, that is equal to 4500 into 20, 90,000 joule. This is work done by the load. So we got the value expressed in joule. Now the second part, B part, work done by the effort. Work done by the effort, WE. You know the formula, effort into displacement of effort. The effort is given there, but displacement of effort is not given. How to calculate displacement of the effort? We know that velocity ratio is equal to distance of effort to the distance of load. Therefore, velocity ratio is equal to, it is given 4 is equal to distance of effort is not given there, keep it as dE by displacement of load is 20. Therefore, displacement of effort is equal to 4 into 20, that is equal to 80 meter. So, displacement of effort is equal to 80 meter. All right? Yes. Now, we can solve work done by the effort. Work done by the effort is equal to effort. What is the value of effort? 2500 into what is the value of displacement of effort? 80. Therefore, we get it as 2500 into 80. What is, how much it is? 200,000 joule. 200,000, 2 lakh joule. Work done by the effort. So, we calculated work done by the effort. Okay. Now, moving to the third part, name the two types of work done. What are the two types of work done? Work done by the load. Work done by the load, that we call it as work done on the load. Sorry, it is work output. Work output, that is work done on the load, that is equal, we call it as work output, and work done by the effort, WE, is equal to work input. Work input. Work done by the load, work output, work done by the effort, work input. So, the third part is solved. Calculate the efficiency of the system. Next, the fourth part, calculate the efficiency of the system. We have to calculate the efficiency eta of the system. Efficiency eta is equal to, you know the formula, work output upon work input into 100 into 100, because we have calculated work output and work input. If you calculate the ratio between work output and work input, you simply get the efficiency. Therefore, efficiency eta is equal to how much? Work output 90,000 divided by 200,000, 2 lakh, into 100 into 100, that is equal to how much? Cancels. Efficiency, I am writing here, efficiency is equal to 0.45 into 100, 0.45 into 100, that is equal to 45%. 45%. All right. So, we have calculated the efficiency of the pulley system as 45%. I hope it is clear to you. Now, moving on to second question of this session. A pulley system has 5 pulleys in all and is 90% efficient. Calculate first the mechanical advantage, second effort required to lift a load of 100 Newton, and the last questions, resistance due to movable parts of machines and friction. Have a look at the problem and try to note down the quantities given there. Number of pulleys 5, efficiency 90%, velocity ratio is equal to number of pulleys, that is equal to 5. First, you have to calculate the mechanical advantage. The first part, we know the formula, efficiency is equal to mechanical advantage upon velocity ratio into 100. What is the value of efficiency given? 90 is equal to mechanical advantage, we have to calculate, it is an unknown quantity, divided by 5 into 100. Okay. Therefore, mechanical advantage is equal to 90 into 5 upon 100 to 9 by 2 is equal to 4.5. We are getting mechanical advantage as 4.5. It has no unit since it is a pure ratio. All right. The question number 2, what does it demand? To calculate the effort required to lift a load of 100 Newton. What is the effort required, put a question mark, to lift a load of 100 Newton? Very simple. We know that the formula, mechanical advantage is equal to load upon effort. Effort is required, therefore effort is equal to load upon mechanical advantage. Clear? Effort is equal to, what is the load? 100 upon 4.5. 100 divided by 4.5. How much it is? It is coming as, calculate and see, 22.2 Newton. 22.2 Newton is the effort required to lift a load of 100 Newton. Okay? Yes. Now, the last part of the question. So, it seems a bit complicated. What is the last part of the question? We have to calculate the resistance due to movable parts of the machine. Resistance due to, third part, resistance due to movable parts. You know that the movable parts of the machine offers resistance. We have to overcome that. We know that the formula, which we have already discussed in the previous module, you must be thorough with all the formulas in order to solve the numericals instantly. Mechanical advantage is equal to velocity ratio minus W upon E. What is W there? I had told you W is the weight of the movable parts. From here, we want to find out W, the weight of movable parts. All right. So, we can write W is equal to, very simple, E into VR minus MA, velocity ratio minus mechanical advantage. Am I correct? Please check it. W is equal to E into VR minus MA. Correct. All right. Now, put the value. We adjust the formula here from the given standard formula. W is equal to, that is resistance due to movable parts, E. What is the E? We got it, effort 22.2, velocity ratio 5 minus 4.5. Therefore, W is equal to 22.2 into 5 minus 4.5, how much? 0.5. Multiply and see the value. We are getting it as 11.1 Newton. 22.2 into 0.5. So, all the first part and second part was bit easy, but third part was bit confusing. I hope all of you understood. All right. Now, proceeding to question number 3. The diagram shown in figure 3.25 gives an arrangement of single movable pulleys. Copy the diagram if the effort applied at the free end of the string is E. Show the direction of magnitude of the forces exerted by 4 strings marked 1 to 4. What is the load which can be lifted up by the effort? And the last, calculate the mechanical advantage of the system of pulleys. Please read the question again and try to understand. It's very easy questions. We can solve it. Now, look at the diagram which is drawn on the board. As you can see, it is a single movable pulley system with the 2 fixed pulleys attached. The function of 2 fixed pulley is to change the direction of the effort applied. Okay. The first part, show the direction and magnitude of the forces exerted by 4 strings marked 1 to 4. The strings marked as 1, 2, take it as let it be 2, 3 and 4. Okay. So, mark the forces acting. Is a tension, direction of tension is acting vertically upward, tension here, here also tension, 1, 2, 3, 4, here also tension, T. So, all the tension acting along the 4 segments of the string. Here also one more tension which is balanced by effort. Okay. So, we have marked the direction of the tension acting along the 4 segment of the string. First part is over. Moving to second part. What is the load which can be lifted up by the effort? So, in equilibrium, when the pulley is not rotating, load will be balanced by the load acting here, which is vertically downward, will be balanced by the tension acting along the 4 segments of the string. Therefore, L is equal to T plus T plus T plus T, L is equal to 4T. Okay? Yes. So, the effort load will be equal to 4T. Yes. Now, what is the, moving to the third part, calculate the mechanical advantage of the system of pulleys. The third part of the question, you have to calculate mechanical advantage. Very simple. In equilibrium, we know that load is balanced by 40. This load is balanced by 1, 2, 3 and 4 T's, 40. Okay. And what about effort? Effort is equal to T. Okay. Therefore, mechanical advantage is equal to, we know the formula, load upon effort, substituting the values in the formula, 4T divided by T, E is equal to T. So, Tt get cancelled. So, mechanical advantage we are getting it as 4. The mechanical advantage is equal to 4. Steps are clear to you? Okay. Proceeding to question number 4. A pulley system can lift a load of 1200 Newton by an effort of 250 Newton. If the resistance due to weight of mobile parts and friction is 300 Newton, calculate the first mechanical advantage, second velocity ratio, third total number of pulleys in the system, and the last efficiency of the system. Now, let us solve. At first, what you have to do when you get a problem, read the problem very thoroughly and try to note down the values given there. What are the values given there? A pulley system can lift a load of 1200 Newton. A load of 1200 Newton is given by an effort of 250 Newton. Effort is equal to 250 Newton. Okay. If the resistance due to weight of mobile parts and friction is 300 Newton, the total resistance, let it as resistance due to friction of the moving parts, take it as W, that is equal to how much it is given? 300 Newton. All right. So, we have found out all the values given there. The first part of the question, mechanical advantage. What is the mechanical advantage of the pulley system? Mechanical advantage is equal to load upon effort. Very simple. What is load? 1200 upon 250. That is equal to, calculated 120 divided by 25. It is coming out as 4.8. It has no unit. It is a pure ratio. So, we got the mechanical advantage as 4.8. What is the second part of the question? Velocity ratio. You have to calculate the velocity ratio here. Velocity ratio. So, velocity ratio, you know that it is equal to mechanical advantage, ideal mechanical advantage. What is mechanical advantage? Mechanical advantage is equal to total load upon effort. We know the formula, mechanical advantage is equal to load upon effort. We are applying the total load because we have the load which is to be applied and another resistance due to friction, that is also known as the load. That is, total load will be equal to the load which is to be lifted, L, plus the resistance due to friction, that is also kind of load, W upon effort. All right. Okay. So we can write the mechanical advantage is equal to velocity ratio, that's equal to L plus W. How much? Load is 1200 plus W, that is resistance due to friction, that is 300 upon effort. What is the effort? 250 Newton. Therefore, velocity ratio is equal to 1500 divided by 250. That's coming out as 150 divided by 25, 6. So we got the value of velocity ratio as 6. Now, what is the question there? Read the question. Third question. What is the third question out there? Total number of pulleys in the system. What is total number of pulleys? I am writing here. Total number of pulleys. Total number of pulleys is numerically equal to velocity ratio. All right. So the total number of pulleys is equal to 6. That is equal to velocity ratio, which you have already calculated. All right. That is the third part of the question. Moving on to the last part of sub-part of the question. What do you have to do there? Efficiency of the system. You have to calculate efficiency. What is the efficiency there? Very simple. We know all the quantities there, just substitute, direct substitution. Efficiency is equal to, we know that eta is equal to MA upon VR into 100. We know the value of mechanical advantage 4.8. We know the value of velocity ratio as 6 into 100. Just solve and see. Very carefully, we are getting it as 80%. So we got the value of efficiency as 80%. Okay, efficiency is equal to mechanical advantage upon velocity ratio is equal to 100. We have calculated all the quantities. Just put the values and calculate it. So I hope the steps are clear to you. Now moving on to the last question of this session. Question number 5. Let us read the question. A machine is operated by an effort of 80 Newton acting downward and moving through a downward displacement of 0.15 meter. The load of mass 10 kg is raised up by 10 centimeter. Calculate the mechanical advantage, velocity ratio, work input, useful work output and efficiency. The value of G is given as 10 meter per second square. Now let us solve question number 5. Whenever you get a numerical problem, we have to read the problem again and again and note down the values given. What are the values given? A machine is operated by an effort of 80 Newton. Effort is equal to 80 Newton given. Acting downward and moving through a downward displacement of 0.15 meter. Displacement of effort is equal to 0.15 meter. All right. Load of mass 10 kilogram. What is the load there? Load is given in 10 kilogram mass. That should be converted into the unit of force. Therefore, that is equal to 10 into 10. 10 it's equal to 100 Newton. So load is 100 Newton. All right. It is raised up by 10 centimeter. Displacement of the load is given 10 centimeter. So this is the value in CGS unit. You have to convert into SI unit 10 centimeter is equal to, it is 0.1 meter. All right, displacement of load is equal to 0.1 meter. Okay. Calculate the mechanical advantage. First part of the question is mechanical advantage is how much? By definition, we know that mechanical advantage is equal to load upon effort. That's equal to how much? What is the load? 100. Look at the values given, divided by effort is equal to 80. 10 by 8, we are getting it as 1.25. Calculate it and see. 1.25. All right, mechanical advantage 1.2. Second part of the question, what's given there? To find out velocity ratio. Velocity ratio, by definition, you know the formula, displacement of effort to displacement of load. You should be very thorough with the formulas. What is displacement of effort? 0.15 meter divided by displacement of load, dl, it is equal to 0.1 meter. How much? 0.15 divided by 0.1. Just calculate and see, it is coming out as 1.5. So, the velocity ratio is 1.5. All right. Next, the third part. What is third part? Work input. What is the work input? Work input. So, your work input, we know that work done by the effort. So, work input, force into displacement, effort into displacement of effort, E into dE, we know the formula. That is equal to what is effort? 80 into displacement of effort 0.15 meter, right? Displacement of effort 0.15 meter. That we are getting it as work input. Just multiply and see. That is equal to 12 joule. 12 joule. That is the unit of work. All right? Yes. Useful work output. What is the fourth part? What is the work output? Useful work output. How much work we are getting as the output? So, you know that work output is equal to, it is done on the load, load into displacement of load, load into displacement of the load. What is load? 100 Newton into, what is displacement of load? 0.1 meter. Displacement of load, check it, yes, 0.1 meter. So, we are getting it as 100 into 0.1 meter, multiply and see, that is equal to 10 joule. Joule is the unit of work. Okay. Now, the last part, I am solving it here. What is the last part? Efficiency. That is last part, fifth part, efficiency. Efficiency is equal to, you know the formula, right? Efficiency in terms of work output and work input. We can write work output divided by work input, okay, into 100, into 100. Okay. So, what is work output? We got it as, please check, 10 divided by work input, how much? 12 into 100. Solve it, we are getting it as 83.3% efficiency. So, the efficiency we are getting it as 83.3%. I hope steps are clear to you. Please do it again and try to do it by yourself. That's all for today's session. Please subscribe, share and press the bell button for more interesting videos to come up. Thanks for watching ICSE Physics, keeping intellectually engaged. Thank you very much. Stay tuned with us.